When we're building out a network, we want as much bandwidth as possible while reducing our latency and at the same time having some redundancy built into it. But we run into a certain challenge with the layer 2 protocol called spanning tree that likes to shut certain links down. In this video, I'm going to go into how Cisco Nexus switches have a unique way of getting around spanning tree. Hi, I'm Rich and welcome to the Rich Tech Guy channel. And in my previous videos about VXLAN and ACI, I've hinted at VPCs with the Cisco Nexus switches. So in this video, I'm going to dive into VPCs and we're going to go into how they operate and even how to set them up. And if you like this content, go ahead and hit that like button. And if you're new to this channel and you're looking for more content like this, go ahead and hit the subscribe button as well. So, going back to some basic networking concepts, we've got two switches. We want to set them up and connect them together. So we put a trunk line between them. Great, right? But what happens if that link fails? Well, now we got to get somebody over there to go cable a new link or diagnose the problem. So let's build in some redundancy. We create a second link. Okay, so now we have a second link. Everything so far so good, right? Well, no, because now spanning tree shows up. And spanning tree sees a potential for a loop between the switches and it shuts down one of the links. And what we have now is we have redundancy, but the failover time can take up to 1 minute. So that's really no good. And on top of that, we're only using half of our available bandwidth. So what we do to get around that is we create what's called a port channel. We logically combine the two links as one. So spanning tree sees those two links as a single link and keeps it open. That's great, right? Well, let's expand that now into a tiered model where we've got 4 switches. We have 2 distribution layer switches and we have 2 access layer switches. Okay, so now we've got port channels running in between them. But the problem is our networking frenemy, spanning tree, shows up once again and sees a bunch of potential loops across this. So spanning tree goes and starts shutting down entire port channels. And once again, while we have the redundancy, our failover times are up to 1 minute long. And we are not using our full potential bandwidth. So in 2009, Cisco launched the Nexus line of switches. And with that, they introduced a new technology called virtual port channeling, or VPC. And what that does is it combines 2 Nexus switches that operate and work together to do their own loop mitigation procedures. And then what they'll do is they kind of convince spanning tree that they are the same switch, and thereby tricking spanning tree into allowing all of the links to stay open. Okay, so when we're configuring a VPC, there's some factors that we have to keep in mind. First of all, the VPC has to be configured between Nexus switches of the same family. So if you have a Nexus 7000 series switch, you have to pair it with another Nexus 7000 series switch. Now when we get into the Nexus 9000 series switches, which are the current line of Nexus, that is where we start having to even dig a little bit deeper. So for the Nexus 9300 series switches, they have to actually be paired up with a Nexus 9300 of the same switch model. For example, a Nexus 93-180YC-FX3 has to have a VPC with another Nexus 93-180YC-FX3. If we're doing a VPC between 2 Nexus 9500 series switches, then we have to do it between line cards. The line cards of those 2 Nexus 9500 series also have to match. So once we've got the hardware components worked out, when we're actually going and configuring it, there's some things that we have to run between the 2 paired switches. We have to have a layer 3 peer keep alive connection, and then we also have to have a layer 2 VPC peer link. Now here is something that we have to also keep in mind with that, is the layer 3 peer keep alive cannot go across the layer 2 peer link. So in other words, you cannot set up switched virtual interfaces on the two switches and run the peer keep alives between them, because it will do so across the layer 2 peer link. So there's two ways we go about deploying a peer keep alive as a layer 3 connection. One of those ways is on each switch you dedicate an interface as a layer 3 routed interface. You assign the IPs and you run the peer keep alives through that. This is not the preferable way because it utilizes up one of your switch ports. So the other way you go about doing that is to use the management interfaces. Every Nexus switch has a management interface on it, and even if it's going through a management switch, it doesn't matter. You can essentially tell the peer keep alive to point the two management interface IPs at each other and just bounce the hello packets between them. If it goes through another switch, management switch in between, no big deal, as long as they still send and receive the hello packets. All right, so once we've got that all set up, then you create your port channels like you would normally, although you may only be creating a port channel of a single link on each switch, and you run your connections to your downstream switches or devices. It could even be a server, like say a VMware server with NIC teaming. And then you assign those port channels VPC IDs, and you're ready to go. So let's go into a lab environment, and I'm going to actually set up a VPC and we'll take a look at how that's done. All right, so here's my lab setup where I have two Nexus switches. These are going to be acting as distribution layer switches. And then I'm also, as essentially access layers, I'm running two Catalyst switches. It could be a Nexus switch downstream, but one of the reasons I particularly chose Catalyst switches for this exercise is because Catalyst switches are not VPC capable, but yet they can be a downstream device for VPC. So just to demonstrate that. So let's first go in on our first Nexus switch here. And one of the things I need to do is I've got to go into configure mode. And I first need to enable the feature VPC. Okay, let's do this on the other side too. And while I'm at it, this is not required, but if you want to run LACP for your port channeling, you're also going to need to enable the LACP feature. Okay, so now that I've got these features activated on the NXOS, let's go ahead and start creating it. So first I need to create a VPC domain. So that's a simple command, VPC domain. And if I take a look here, I can pick any number between 1 and 1,000. So let's just do VPC domain 555. All right, I have to configure the same VPC domain on the other switch. All right, now I need to create, I'm in the configuration for the VPC, so I need to create the peer keep alive connection. So in order to do that, it's pretty simple. Peer keep alive, and things kind of work a little weird here. As I said previously, the ideal scenario is to use the management interfaces, so that's exactly what I'm going to do here. What I'm going to do is I first have to do the destination IP address. So this is Nexus switch 1, and I need to connect to Nexus switch 2. So I need to put the management IP for the other Nexus switch in first. And then I have to specify the source. And that is where I'm going to put in the management IP for this switch. Okay, now I could specify the VRF. The management interfaces are in the management VRF. But I don't have to. Because I have given the IP addresses that are in the management VRF, the Nexus switch is smart enough to figure out that this needs to happen inside of the management VRF. So I can just hit enter and we're good to go. Now I have to do the same thing on the other switch, but reverse the IP addresses. Okay, so I've got the VPC peer link configured. At this point, if I were to do a show VPC command, you'll notice, well, it will say the peer link is not connected, but the keep alive status does show that the other peer is there, it's alive. So now we got to go create the VPC peer link. So I'm going to exit out of this. And I need to go create that port channel and assign it as the peer link. So alright, so those are my two interfaces that I have. I'm creating the port channel between the two links. I'm just going to go ahead and create the port channel and then configure it. So we'll give it a number of 10, and since I created LACP or activated the LACP feature, I'm also going to go ahead and do LACP here by giving it the active mode. You can go ahead and exit out of that. Let's go ahead and create this on the other side too. And here I'm going to, once again, create the channel group. All right. So now let's go into the port channel I've created. And we'll do the same on the other side. All right, so let's make sure these are trunk lines. And you know, at this point I could do some VLAN pruning. So I've only got a few VLANs configured for this demo, so we're just going to go ahead and put them in here. And before I issue the next command, I'm going to go ahead and configure out the other side. So okay, so now for the next command, I have to tag this as the VPC peer link. So what I'm going to do there is I'm going to type in the command VPC peer link. It's a real simple, straightforward command. Same thing on the other side. All right, now we've got to give it a moment to come online. So I'm just going to wait here, but now I'm going to do a show VPC. And now look at this. I've got a peer adjacency is formed. It says the peer is alive. I'm seeing a lot of successes here on the consistency, the per VLAN consistency status, type 2 consistency status. So show VPC on the other side. I see the exact same thing, and then right here it shows my status of the VPC peer link. It says everything is good. Actually, I don't have the other VLANs I've created, but I am going to need them, so I'm just going to go ahead and create those VLANs. Alright, so now if I do a show VPC again, alright, the active VLANs are now showing up on the peer link. Alright, so now I've got my links down to my catalyst switches. So I need to go ahead and, in order to get that configured, I need to create the downstream links. So there's one of my links, and that is going to go, I've actually, as part of consistency's sake, what I like to do is have the exact same interface on each switch going down to the downstream device, so that way it just makes configuration easier. Alright, so again I'm going to do a port channel, and I'm just going to do channel group 1 because it's interface 1, and again I'm going to use LACP, not a requirement, but I'm just choosing to do it. On the other switch, same thing. And then for the second switch, we're going to repeat that. But before well, actually first we'll configure out the port channel. Actually, you know what? We'll go ahead and create the other one. So INT-ETH1, and that would be, in this lab instance, it's interface 1, 2. Channel group, we'll make that 2, mode, active. Alright, same thing on the other side. Okay, now let's go and configure out the port channels to the downstream switches. And switch port, mode, trunk. And the VLANs that we're going to allow. Okay, now I have to claim this port channel that I've created, port channel of 1 link on each switch, as a part of the VPC. So on this port channel configuration, the command here is VPC, and then I give it a number. It helps to have the VPC be the same number as the port channel number you've identified, just for making things easier on your life later. So I'm going to make that VPC1, and we're going to say VPC1 on the other side. So let's go and configure the other port channel. And assign it a VPC of 2. Now you don't have to go sequential. You know, if I was doing channel group 30, channel group 40, 50, whatever, I could do that. But as I said, I'm just assigning the same VPC number to match the port channel number that I've configured. So that way, later on, I don't have any headaches if this were a production environment and not my lab environment. Okay. So now, if I do a show VPC, here's what's going to happen. It's going to show that all this is successful. Now I'm seeing two VPCs have been configured. But if I go down, it's actually going to show that my VPCs are down. It says the status is down, consistency, success, reason, success. It kind of looks a little weird at this point. And that's because I haven't configured the port channels on the other side. Once I get those port channels configured, this should all start clearing out. The other thing that it will do, though, is when you have the status of down here, is it's going to give you this little message saying, do show VPC consistency parameters, VPC, and then the number you've assigned, so VPC ID 1 or VPC ID 2, and it will do a cross-reference between the two switches and show you if there's any inconsistencies in the configuration. That's actually quite helpful sometimes. So let's go configure the catalyst switches. We'll just do a straight up VPC configuration. And the way we do that, of course, is we hit the like button. And that's always the first step to anything, right? And while you're at it, if you like this content and you want more of this type of content, go ahead and hit the subscribe button too. So all kidding aside, let's go back into doing the channel group configuration on the catalyst switches. All right, so I'm on the catalyst switches. Let's go ahead and get them configured out. So, typical iOS. One of the things I find working with NXOS is it's a cleaner, smoother style of compared to iOS. So it's always kind of a challenge for me when I go back into the iOS operating system and I might try to do something that it's a much simpler command or easier to do on the Nexus that the catalyst switches make me jump through some extra hoops for. I don't know if anybody else has noticed that. If you did, comment down below. All right, so let's go into this and for example, like on the Nexus switch, I could have just done interface, Ethernet, and given the range of Ethernet interfaces. Of course, here on the catalyst, it's interface range. I have to give it an extra word. And I have to specify the interface type, gigabit Ethernet, 2.1 and let's see, 2.0/2.1, I believe. All right. So again, let's create our port channel here. And of course, the other fun thing about the catalyst, when you tab, it likes to give you a whole new line. All right, channel group, and again, I'm going to do, this is going to be channel group 1 on catalyst 1, as this particular channel group is going to go to interface 1 on each of the upstream Nexus switches. And again, it's LACP that I configured. So let's go into here. I have to define this as a switch port. It's a layer 3 switch, so I have to give it an encapsulation style. Again, these extra catalyst hoops. Okay, before I go over to the other switch here, let's again run a show VPC. And notice VPC 1, port channel 1, is now showing up, active VLANs 1, 10, and 42. Okay, so let's configure the VPC for the other switch and get everything up and running. So this one will be channel group 2 because it's part of VPC 2, and the links on this catalyst switch are going to the Ethernet 2 links on the Nexus switch. Okay, at this point, if I do a show VPC command again, it's all up. Success. If I do it on the other switch, so everything here is up, it's communicating. So let's go take a look at something here. Let's do a show spanning tree for VLAN 10. I'm still learning. You know, it's that minute uptime or redundancy failover time that spanning tree does. Let's see if, okay. So the first Nexus switch is identifying itself as the root. It says this bridge is the root. So of course, as the root switch, everything is going to be in the forwarding state. The designated forwarding state. So let's do a show spanning tree VLAN 10 on the other switch. So it does identify the other Nexus switch as the root switch. But notice how it's tagging stuff here as VPC as the link types. Now if I go down to these switches down here, of course I have to exit out of config mode on these two to run a show command. And yes, I do know about the do command. It only shows one link, but that one link is going to two switches. Same thing on the other side. Again, it's only showing one link, and that one link is going to the two switches. So in the root switch, of course, everything is going to be in forwarding state. But on the non-root switches, everything is in forwarding state. Because spanning tree on these catalyst switches thinks that the link is only going to one switch, when in reality it's going to two switches. So there we have it. We've got our multiple links. We're utilizing our full bandwidth, and that is our virtual port channel configured. Alright, so I hope this video was helpful to you, particularly if you're studying towards a CCNP data center. Understanding virtual port channeling, it's foundational to the Nexus switches, and it is something you're going to have to know for that certification. The other thing is, I'm going to post some resources down below. They are going to be affiliate links for CCNP data center studies, for virtual port channeling, Nexus switches. Feel free to go ahead and check those out. And you know, if you want more of this content, go ahead and hit that like button. Hit the subscribe button as well if you're studying for NP Data Center. And as always, keep studying, keep improving, and I will see you in the next video.